So I said to you that we are re-embarking. We are in the process of market-driven new build, and there are an awful lot of different international plants, all of which would have been available to the UK. Oh, I should say, by the way, if anybody's got any questions, particularly difficult questions, and they want to ask me as we go along, I think we've got plenty of time. I'm more than happy to take questions as we're going along.
Where are you storing the
We're off.
Where are you storing the waste?
So there are a variety of different places that we're storing it. Our low-level waste is at a place called Drig. So these are ISO containers with low-level waste in them, and this will have a few metres of soil stuck on the top of it eventually when the Drig is filled. Drig's about 2/3, 3/4 filled. A lot of that is sort of gloves and things from hospitals and stuff like that. The intermediate level waste is cementatious. So it's things like magnet swarf, the metal containers and things that we wound off with waste. And so it's contaminated metals and cementatious in barrels about this high, which are 304 stainless for those, any metallurgists in the audience? You'll know what I'm at. So it's 304L type containers, but stress corrosion cracking may come up to give us a hard time on that one in the future. We may not have made optimal decisions at the beginning of that one. It's not heat generating, and that's at the moment mostly kept in Sellafield. And our high level waste is in these, at not quite as tall as the ceiling, stainless steel containers, vitreous waste, the vitreous materials poured into those, and those are stored in storage at Sellafield again. And big lead plugs on the top of them. You can walk actually across the room that it's stored.
Underground or?
No, not yet. So in terms of the geological, you bring up a very, very interesting issue actually. So the geological disposal issue, which the Scandinavians of course are making tremendous progress in, we would like to start investigations of finding a rock mass which is suitable for an underground repository. We have something called Quorum, Committee for, well, it's the Committee for Nuclear Waste. I can't remember the acronym exactly it stands for. I'm sure somebody's looking it up on their iPhone already. And it's Quorum 1 sat and came to the conclusion that deep geological disposal is the way to go. Quorum 2's job is to try and put some more meat on those bones, and that's proceeding at the moment. The Majesty's Chief Inspector for Nuclear Installations, Lawrence Williams, is the chair of that at the moment. Lawrence tells me what's going on, because I actually share an office with him. This is part-time professor at Imperial College. Makes that very convenient. That's proceeding. We had, however, and this is the really important bit, we had a process to try and find people who were willing to allow us to do the research to see whether the rock body was suitable at Sellafield. And we had a process, the volunteerism process, which the Scandinavians used, and the local people had to vote yes, the Greater Region Authority had to vote yes, and the government had to vote yes. Not to store, it's to do the research to see whether or not it was sensible geology. The local people said yes, and indeed the adjacent set of local authority had an impromptu vote to say yes, just in case the others said no, because they were keen on the advantages, economic advantages. The government said yes, but the greater authority, which is around the Lake District, I don't know whether many of you have been to the Lake District, area of outstanding beauty, so on and so forth, and they voted no, because they were concerned about the impact on the economic sustain.
Wouldn't some of the old underground coal mines that go out into the sea as such a...
There are a variety of interesting geologies that you can look at. Coal mines are generally not so good because they're a bit leaky, because the rock, lots of methane pockets and things that cause issues with those sort of rocks, and they're sedimentary rocks which tend to be quite porous. You get quite a lot of water movement through. Actually, you do with highly fractured basaltic type rocks as well. Clays is another area. So in fact, London's not such a bad area from a geological point of view.
As a Scotsman, I'll celebrate.
Kent is even better. So clays are excellent. By the way, has anybody heard of, well, we're going right down different rabbit holes here. OCLU. OCLU is the natural nuclear reactor. Yes, there were natural nuclear reactors. If you go back 2.3 billion years ago, the ratio of uranium-235 to 238 was the same as that which we now enrich. The half-life of 235 is shorter than 238, so therefore the proportion changes with time. And so 3 billion years ago, or 2 billion years ago, whenever it was it 1.3? I can't remember, but it's a long time. The rate was just what you wanted for a light water reactor. The uranium ore body had concentrated in sedimentary rocks, then water had ingressed, it had moderated the neutrons, and off it went. And they had a natural nuclear reactor. Sorry, I thought you were going to say something. No? So OCLU, we can look at the geology. It's phosphate-based geology. It's clay-based geology. You have a lot of those geologies in South Africa. And the fission products got about that far in terms of the migration over one hell of a long time. So there are lots of things. So it's complicated. The whole waste issue is quite complicated.
Can I know you want to move on, but can I, abusing the
what you want is the most important.
But there's been quite a lot of discussion over the years about us importing waste from other jurisdictions. And I wonder, when you're describing the amount of waste we store, whether that includes, I mean, you said it's the waste we have produced, but is there other waste that has come in from elsewhere?
Yes, there is. I mean, again, that's a really interesting question. We reprocess wastes from Japan and Switzerland in particular, who were big users of our reprocessing facilities. And we turn that into vitreous materials, and that's been returned back, or is in the process of being returned back to those countries.
So it doesn't add to our waste store?
Well, there are some small amounts of research reactor fuels which doesn't really make sense to send back. Then these are very, very, 0.01% of the entire burden. So there are some compromises that we've made. And I think, for example, we've sent back, in some cases we could, I'm not sure whether we did this in the end, but we could have, for example, sent back extra terabecquerels of active material which was commensurate with the active material that was being sent back to Japan and Switzerland, which we could swap one becquerel for another. There are lots of different sort of tricks that you can pull like that, which are entirely sensible to the IAEA. You have to be pragmatic about these sorts of things. And actually, the plutonium. I mean, one of the things that people always ask me about is mixed oxide fuel, the idea of taking uranium fuel and plutonium and mixing them together to make a mixed oxide fuel, because the plutonium is fissile, and this will use up a certain proportion of the plutonium. And, is this any more or less dangerous? And actually, the point is when you've got ordinary nuclear fuel based on uranium, as it proceeds through the fuel cycle, it actually generates plutonium. So actually all nuclear reactors use mixed oxide fuel. It's just produced in situ as opposed to mixed up at the beginning. So that is an option for the United Kingdom to deal with its plutonium. Whether we will do that or not is not being decided yet. So in terms of new build,
just a question on new build. I know you missed off the most widely exported reactor in the world.
the VVER.
Yes. Most loops, some of the best safety features.
The best, sorry?
Safety features.
I'm sure.
Sterling in general.
Yeah, no. I'm sure that if you were to ask Ariba, or you were to ask Hitachi, or you were to ask Toshiba whether or not they had the best safety systems in the world, I'm sure that they would say that their reactors have the best safety systems.
That would be really sound.
However, and I am now definitely putting my Imperial College hat on at this point, and this is not a government position or anything like that. From a purely engineering point of view, my opinion is that the VVR reactor, as a reactor, is an entirely sensible design. Particularly the metallurgy of the, I have looked a little bit at the metallurgy of the pressure vessel itself and the design of the pressure vessel, and also the design of the core. And we also should remember that the cladding for the nuclear fuel that is used now more and more internationally, the niobium alloys, in fact are Russian alloys. They aren't Western alloys at all, they are Russian alloys. So although I wouldn't for a second say that it was more or less safe than the other reactor designs, I certainly wouldn't say that it wasn't a bad design. I wouldn't say it was a bad design at all. I think it's a very interesting design, indeed. And it's a very solid reactor. We might have some interesting discussions about control systems, and I think it's a shame that there isn't more international collaboration on the VR control systems.